Welcome once again to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, I'll be explaining example 2 of IGCSE 9-1 under the topic Shape and Space 6. And this one, we are just supposed to prove that XY meets OZ at right angles. XY meets OZ at right angles. In other words, you're supposed to prove that that is 90 degrees. And the moment that is 90 degrees, even this one angle is 90 degrees. And the moment this one is 90 degrees, even this one is 90 degrees. All these are 90 degrees. We are supposed to prove that those angles measure 90 degrees. And let's just start with, if you look at it keenly, you will find some features given in this diagram. For example, this line segment YZ is parallel to OX. Parallel, you can see the arrows. Those arrows show those two lines are parallel. And therefore, the line or the chord XY happens to be a transversal. Transversal means when you join two parallel lines with a straight line, that line is called a transversal. And there are so many features within parallel lines. For example, this angle, which is 30 degrees, is alternate, or it is alternating to this angle, so that this is also 30 degrees. By what feature? Angle OXY is also 30 degrees. Because of what reason? Because of what reason? Are alternate. And this is, the reason is it alternates to angle ZYX. Angle ZYX, the angle which is given 30 degrees, it's alternating angle OXY, that one and that angle, alternate angles. Okay, having reached there, it is also important to note angle OYX is also equals to 30 degrees. Why? Let us evaluate the reason. You realize that this is a radius which is equals to this other radius. And because angle OXY happens to be an isosceles triangle, and we know that base angles of isosceles triangles are equal, so even that angle is 30 degrees. Reason being base angles of an isosceles triangle are equal. The base angles of an isosceles triangle are equal. Triangle OXY is isosceles due to the fact that this is a radius and this is the radius of a circle, and two radii are equal, making the whole triangle isosceles. So that base angle is equals to this base angle. It goes without saying. Let's talk about, let me explain why angle YZO is also 60 degrees. The reason why angle YZO is 60 degrees is 60 degrees. YZO is 60 degrees. If that is true, then due to the same fact of the angles of an isosceles triangle, because at the same time you realize that even OZ is a radius, that OZ is a radius. And since this happens to be one base angle of triangle OZY, this is the other base angle, which is also supposed to be 60 degrees. And the reason being is base angles of an isosceles triangle are equal. And what triangle are we talking about? Triangle OZY. Here we were talking about triangle OXY. So those two, the angle OZY or YZO is also 60 degrees. Now, if we consider this particular point and call it point N, call it this particular point of intersection, point N, considering now, considering triangle or Z and Y, this triangle Z and Y, and let's just extract it here. Let's have it here. Let's extract it here. This is Z, this is N, and this is Y. Basically, we can see that angle is 30 degrees, that angle is 60 degrees. So it goes without saying that angle is 90 degrees. Then angle Y and Z is 90 degrees. Reason being, angle sum of a triangle is 180 degrees. And of course, when this one is 90 degrees, if we go to the main diagram, y and z is 90 degrees, then you can already see that the chord xy meets OZ at right angles, and it has been proven. Then this proves that xy meet OZ at 90 degrees, and it's as simple as that. All right.